We're going to be talking today about acid-base reactions. So acid-base reactions, we know this commonly as the neutralisation reaction, and we would have talked about this in Module 3 and also briefly in the chemistry section of the Year 10 science topic. Now, acid-base reactions in the Bronsted-Lowry theory are going to be reactions that involve the transfer of protons or H+ ions, because as we remember, acids and bases were defined as being these proton donors or proton acceptors. However, acid-base reactions in Arrhenius theory are going to always produce water because of the reaction between H+ and OH-. But actually, not all neutralization reactions are going to produce water. And an example of that is right here. NH3 plus HCl gives us NH4Cl solid. But what is this NH4Cl, this ammonium chloride? Well, this is what we call a salt. Now, all neutralization reactions are going to form salt. And what are salts? They are ionic compounds that consist of an acid anion and a basic cation. So let's look at this example here, which is the acid and metal reaction. So acid and metal gives us salt and hydrogen gas. And with our overall equation, we get hydrochloric acid that reacts with sodium and a solid. And that gives us sodium chloride, which is our salt, and hydrogen gas. Now, we can talk about stepwise equations. And what this is what really is going on. What are the step-by-step equations which occur, which help us end up with this reaction over here? So there are actually reactions in between this, which we will talk about now. So what happens at the start is actually sodium metal is going to react with water. So that sodium metal reacts with water and it forms sodium chloride, which is, sodium hydroxide and hydrogen gas. So hydrogen gas is going to be this one over here, okay? Then afterwards, this sodium hydroxide is going to neutralize with this hydrochloric acid, and that is going to form the NaCl solid and the water. But this is going to be dissolved, which is what gives us our salt NaCl over here. So these are the stepwise equations which are happening in this overall reaction. You might be wondering why we don't have any water in here. Well, when we put these reactions together, these ones cancel out, and then the water is going to cancel out after I have balanced it. So how do I know that I made hydrogen? Well, we're going to use what we call a pop test. So when the hydrogen gas is lit in the presence of water, it's going to react to form water to produce a squeaky sound. So when we're doing our reaction, we might cover it with an upside down test tube and let the hydrogen fume into that test tube. Then we're going to light it up with our match, and if we see a pop, this is what's going to happen. We know that we have hydrogen because we form water. Now let's look at this one, which is acids and metal hydroxides. So we just need to remember acids plus metal hydroxides gives us salt and water. So hydrochloric acid reacts with sodium hydroxide. That gives us NaCl and water. Acids and metal oxides also give us salt and water. So magnesium oxide plus H2O is going to give us magnesium hydroxide. And then that hydroxide then reacts with the hydrochloric acid to give us MgCl2 and H2O. Then we go with the acids plus metal or hydrogen carbonates. That gives us salt, water, and carbon dioxide. This one's quite easy to remember because out of the ones that create the carbon dioxide, we just need to remember that it's the carbonate, CO3. Right? You can see the CO3 contains the CO2 plus an extra O. So HCl plus CaCO3 is going to give us calcium chloride. That's our salt, water, and carbon dioxide. So that carbon dioxide is going to be coming from here. Now we look at this other example, which is hydrogen carbonate. So we're using sodium hydrogen carbonate in this case. It's exactly the same thing. HCl plus NaHCO3, we get salt, water, and carbon dioxide.